Good afternoon to one and all gathered over here. Myself, Dr. K. Menaka, Associate Professor, EC Department from Velamal Institute of Technology. Here, in today's class, we are going to see about the geometric transformation, which plays a major role in image processing as well as in the computer vision domain. Here, geometric transformations. What do you mean by the term geometric transforms? It is nothing but it permits the elimination of geometric distortions that occurs when the image is captured. That is, whenever we are capturing the real images in real time, there may be a geometric distortion due to shaking of the camera or due to the wind. So here, in order to eliminate such geometric distortions, we are going for geometric transform. Okay, first we are entering into the spatial transformation. What do you mean by spatial? As you all know that coordinates is nothing but spatial coordinates. X comma y. It is nothing but the location in the image. So the spatial, these location x comma y coordinates is called as the spatial coordinates. A spatial transformation of an image is a geometric transformation of the image in the coordinate system. For example, if we are capturing the image, if the wind is moving, if the wind is there, automatically there will be movement in the leaves. So automatically what happens, the actual location has been moved from to some other location. So that is called as the spatial transformation. In the spatial transformation, each point x comma y of an image A is mapped to the point u comma v in a new coordinate system. So this is the actual location and this is the transformed location. So this is called as the spatial transformation. Okay, the most important question, why where we can use this geometric transformation in the real life? It is nothing but some persons is clicking pictures of the same place. If you see this shipboard, somebody is capturing this shipboard. The same person is capturing the same shipboard in another view. So thing is, it is not necessary he clicks the picture at the exact same angle. So for better visualization, if we want to get both are same information, the ship, but the angle is changed. So for better visualization, we can align these image and this first image and the second image using geometrical transformation for better visualization. So whenever we need the, we will be taking n number of clicks to get the correct image. So during that, in order to get the exact position of the particular object in the image in a single, as a single image, we can use a geometric transformation. So what are the types of geometric transformation? Translation, rotation, scaling, shear, affine, and nonlinear. So these are the six types of geometric transformations. We are here in the next forthcoming slides. We are going to see each types of geometric transformations with the examples. First is the translation. Translation is nothing but it is just shifting the object's location. Translation is nothing but the shifting of object's location. For example, you see the first image. Here, the football is kicked by the player. And if you see the second image, it is the same image, but only this portion has been moved. So what is that? So that is the shifting of object location. So if you know the shift in x comma y direction, you can create the transformation matrix as follows. This is the first image. So here this portion is shifted in the next location. So this is called as a transformation matrix. Whereas x comma y is the where the x comma y in this picture, here this is the x comma y location, and these x comma y location, this is tx comma ty, this location has been transformed to this location, that is the transformed location is called as a u comma v. So from the exact location x comma y to the transformed location u comma v, both are same information, so that is called as a translation. So shifting of objects location. Next is the rotation. As we all know from the word itself, rotation is nothing but it is just a technique rotating an image by a specified angle given by the axis or point. For example, you take this image and this is rotated in the anti-clockwise. So according to the angle given, the image will be rotated. So the rotation is nothing but rotates an image by a specified angle at a particular axis or point. These points may lie outside the boundary of an output image or ignored. Okay, so you assume that this is the original image and we want to rotate this image. This is the another image. When we are rotating this image, so this portion is outside the boundary which has been ignored. So that is called as a rotation. So most probably we will use cos theta and sin theta for indicating the angles in images. So x comma y is the original position and original location, and u comma v is the rotated location. So we can extract u comma v from x comma y using this formula. Next is the scaling. Scaling means it is nothing but resizing an image, which means an image is made bigger or smaller either in x direction or y direction. For example, you take this image. For example, we have taken the image which is of size 300 cross 400 and we want to transform it to the 600 cross 200. How it happens? So it is nothing but that is called as a scaling. Scaling is nothing but we are resizing. Scaling is nothing but we are resizing the image in either x direction or y direction, either longitudinally or latitudinally or horizontally or vertically. So the scaling in x direction is nothing but in what shape we want to transform the image. You just divide that x by the shape that has to be transformed is divided by the given input size. For example, 600 divided by 300 is equal to 2 and 200 divided by 400 is equal to 1 by 2. So in this, the input image is of size 300 cross 400, that is 300 rows and 400 in column wise. So after we are transforming this, we got this size. So the size of the x is 2 times bigger, whereas the column of the input image is half of the input image. So that is called as a scaling. So scaling is nothing but resizing an image, which may be either the image is made bigger or smaller in x and y direction. So the given image size is 300 cross 400, but here the x coordinate is doubled by the factor 2 and y coordinate is half of the input width. So this clearly explains the resizing concept through scaling process of geometric transformation. Next is the shearing. Shearing is nothing but it means shifting the pixel values either horizontally or vertically. So this is the original image, and this is the shearing part. So what we have to do is horizontal shearing is nothing but we shift the upper part we shift the upper part of the we shift the upper part of the right or the lower part to the left. So that is called as a horizontal shearing. If we are coming for the vertical shearing, it is either upward or downward. So this is called as a shearing. So shearing is of two types, either horizontally or vertically. Next, transformation. Rigid transformation is nothing but it is a combination of translations and rotations. What do you mean by translation? Translation is nothing but shifting the object location, that is from xy to u comma v. What do you mean by rotation? Rotation is nothing but the image is changing its location by specifying a particular angle. So the combination of translation and rotation is called as a rigid transformations. Similarity functions. It is the combinations of translation, rotations and scaling. As we all know that translations, rotation, scaling is nothing but it is resizing the image either to the bigger or smaller size. The similarity transform is that whenever we are performing the geometric transformations, it preserves the shape. So that is the main advantage of this similarity transform. Next is the affine transformation. Affine transformation, it is a combinations of translation, rotations, scaling and shearing. Most of the applications, this affine transformation has been used. Example, if we are coming to the real-time example, for image registration techniques, they will be using this geometric transformation. So this is the original image, and this is the rigid transformed image, and this is the deformable image of the original image, and this is the similarity transformed image, and this is the affine transformed image. So through the affine transformation, we can able to clearly identify the deformable part. So these geometrical transformation plays a major role in identifying the deformable part, especially in the image registration applications. So this is a 3D spatial transformation. XY indicates the 2D, whereas 3D means we have to project the 2D coordinates in a 3D, X, Y and Z. So that's all about the geometric transformation. So in this class we have seen what is geometrical spatial transformation, and with the real-time example we have clearly seen the topic of geometric transformation. Thank you.